guys, welcome to the Mathematician. Today I'm going to be going over the STAAR Algebra 1 2017 EOC Algebra 1 EOC test. This website is the practice test for STAAR testing. So if you want to check out this website's actually really nice. It's just like a demo of like how the online STAAR is. So I'm going to click practice, and I'm going to click, it's loading, I'm going to click 2017 EOC, and then I'm going to click Algebra 1, and then no PNP, and take test. This is just like a practice test, sort of, and it gives you the demo version / practice STAAR. See, Algebra 1 2017 practice STAAR. So it's just a practice STAAR basically. Honor statement, agree, next. This just gives you instructions on how to navigate it, available tools, and then stop. But you know, this is like a practice test, so so I've done 1 through 13. Yep, 1 through 13. So let me do 14 through how many ever I get to. The graph of the quadratic function f is shown on the grid. What is the y-intercept of the graph? We know the y-intercept is where, just where it touches the y-axis, right? So it touches the y-axis over here at 4. So we know our y-intercept is 4. And we just input our values plus. This gives you kind of like a feel of how like STAAR is going to be. This is I feel like this is like kind of more beneficial, instead of like just taking it on I guess like quizzing yourself sort of. I feel this is kind of better. And yeah, a particular type of cell doubles in every hour, so we know it's times 2, right? Because doubling meaning not times 2, I mean like it doubles, yeah, times 2, I meant, yeah, my bad. Which function is used to find the number of cells that are present in h hours if there are initially 4 of the cells. So remember our rule of exponential functions. Our beginning value is the number which they started. So we can see here, so we know it's, okay, so all the answers are, have 4 in it. So we know it's not D and C because this doesn't look like how it would be if it's initial value. So it has to be either A or B, right? So let me like cross out our stuff. So it doubles every 2 hours. So we know it's not like doubling every half hour. So it wouldn't be A, and it doubles every 2 hours, every out, like so like 1 every 2 is the rate, right? So it's increasing by times 2, right? So it's like you have to add 2, so it would be B. And if you want to check it out, you can just plug in numbers and check it out to see if you're right. Oops. Erase. Oh, clear. Blah. Okay, sorry. Which is the slope of the line represented by 5x minus 12y equals 24. One thing I like about this software is obviously because they have the graphing calculator, right? Like they give you the graphing calculator right here, so it's easier for me to show. But so in this question, what is the slope? We know the slope is the x value, right? And we the y value isn't by itself, right? So we have to change this into slope form, right? So we move this 12 to the other side, and then move this 24 to the other side, right? So we have 5x minus 24 equals 12y. So we get rid of the 12, right, by dividing by 12. So we're left with 5 over 12. So we just know that y is by itself, right? We don't have to solve for this part because we already know. Okay, our slope is 5 over 12 because our slope is y is equal to mx plus b. M is the slope. So y is equal to 5 over 12x minus 24 over 12. So we know our slope is 5 over 12. Which expression is equivalent to 6x squared plus 13x plus 5. So when we do this, I like to use the x method. So if we draw our x, what times what equals 5? Well, let's go with 1 and 5 because that's obviously the only answer choice. 1 and 5 or 5 or 1, but let's just do 1 and 5. And then what times what equals 6? 3 and 2. If you multiply them, you get 6, and 1 and 6, if you multiply them, you get 6. So now, which one would be more logical? Put the 6 here. 6 times 1 is 6 times 1 is 6, plus 5 times 1, which is 5. 6 plus 5 is 11, not 13. So, this solution set wouldn't work. 3 and 2. Okay, let's put 3 here. No, actually, let's put 2 here and 3 here. 2 times 5 is 10. 3 times 1 is 3. 10 plus 3 equals 13. So we get our middle value. So we have our correct equation. So the correct equation is 2x plus 1 and 3x plus 5. Oops, that looks like a minus, but it's a plus. So if we look at our answers, it is 2x plus 1, 2x plus 1, 3x plus 5. It is C. Oops, that still looks like negative. Okay, so let's see. Oops. Number 18. 18. This seems easy, but I guess I'll just skip it for now because it's probably gonna take a lot of time doing all the work, and I will add it back to, I'll make a separate video for it, okay? 19. How the table shows the heights and lengths of several rectangles. What does the correlation coefficient for the data indicate about the strength of the linear association between the height and length of these rectangles? So it's asking for the what is the linear association. So first of all, if you don't have diagnostic on, make sure you have diagnostics on. How to on diagnostics? Oh, I haven't on it in this calculator yet. You do second, catalog, and then you go to C, A, B, C, D. So we go to D, diagnostics. Yep, right there. You see this button, and then you click enter, enter, and it's done. So we know this is a linear function. So when it's a linear function, we have to look for the r squared, okay? So now our diagnostic is on, right? So we have to plug in all these values into stat. I don't want to waste time showing you guys how to plug in the values. So if you don't know how to go to stat, you click stat, edit, and then you plug in all the values. And stat basically helps you find the slope. And just like stuff like that. Why is it not letting me? I will pause the video and hope you plug in the values, and let's see what we get. I've inputted all my x values, the height in inches. So now let me input all my y values, the length. So now I've inputted all my y values. Let me put this in screen. So after we've done that part, we have to click stat, then click calc, and then so we know it's a linear function because it said linear function over there. Show linear association. So we click for, okay, let me X out because it's acting a little weird. So we click for enter, 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 and then we see we have our A value, B value, R2, R squared, and R. So that's why we on the diagnostic, because that tells you whether it's like what correlation it is. So as we can see in the diagnostics, that our diagnostic says 0.0241 blah blah blah, right? So so we know it's 0.2. So we know it's a positive diagnostics because the number isn't negative. When you're doing linear functions, make sure you look at the R squared diagnostics, not the R. It's not a negative correlation. So we know it's like less than, if it's closer towards 1, it's more positive correlation. This is like a weaker positive correlation, so it's C. Okay. Number 20. The expression x cubed times x to the power of -17 is equivalent to x to the power of n. What is the value of n? This question is very, very common. Many people get really confused of whether to add the exponents, multiply them, and so a handy dandy checker if you're like really confused during the test, you don't even know what you're doing. I'd look at the formula chart. First thing, product of powers, a to the power of m times a to the power of n is an plus n, and this one says a to the power of n, and then a parentheses to the power of n, you have to multiply them. So this one you can see it's multiplying by each other, right? So to add the powers. So let's see. So if we add 3 plus -17, it would be -14. So our answer is -14. Let me type it. Oops. 14. And don't forget your negative signs, because you probably get points taken off if you don't have them, of course. Let's look at this question here. The population of Center City is modeled by the exponential function f, where x is the number of years after the grid 2015. After the year 2015, the graph of f is shown on the grid. Which inequality represents the range of f in this situation? So we know range is the y values, like what from what to what. So it says range, right? So range has nothing to do with x values. So you can automatically just eliminate these, right? And then we have to look. So our x-axis, so our y values don't cross beyond a certain point, right? Anything below this and anything above this is what's there. Anything below this is not there, right? So we know it's 250,000, right? So we know our y values are greater than 250,000 because anything from 250,000, like nothing is below 250,000. So we know it's B. Close, click the answer. Let's look at number 22. Oops. A sequence can be generated. Okay, a sequence can be generated using a sub n equals 4a sub n minus 1 to the power of where a sub 1 is equal to 6 and n. I'm just not going to read it, but it's pretty blah, blah. A sequence can be generated. What is the first four terms of the sequence? So we know our first four terms. Our first term is 6. So we can see here this is basically, you just have to like substitute this into the problem. So 6 times 4 is 24. There's like, this is kind of like a geometric sort of sequence rule, but I don't know how to explain it, but basically when it's like this, you just have to substitute what your a sub 1 value is into this equation sort of, and you just get your answer. Just don't worry about the n minus 1 nonsense. Just do 4 times 6, and then 24 times, and then the second value times blah blah, and blah blah blah. So we can see here our answer is A. Let me press close and click it. I'm actually going to stop the video here for today. Thanks for watching, and please subscribe to my channel. It'll help a lot. Thank you.